Good morning everybody. Hope you're all healthy and safe at home. Let us continue with our section 9.9, Independence of the Path. So in the previous lecture we had seen how to determine the potential function of a conservative vector field in three space. Now we will do a problem which is given in your textbook, that is example 8. That is, we are given the function vector field f, and we are asked to show that the line integral over c f dot dr is independent of the path between the points 1, 1, 1 to 2, 1, 4. And there is another part to this question also, that is we are asked to evaluate the integral also, the line integral. So from the question it is clear that f of x, y, z is nothing but y plus yzi plus x plus 3z cube plus xzj plus 9yz square plus xy minus 1k. This is our f. And what is p? P is equal to y plus yz, q is x plus 3z cube plus xz, and r is 9yz square plus xy minus 1. So just recall what is the process to check whether the integral is path independent. Now to check whether the integral is path independent, we will check whether the given vector field is conservative or not. And what are the conditions to be satisfied? That is, dou p by dou y should be equal to dou q by dou x, dou p by dou z should be equal to dou r by dou x, and dou q by dou z is equal to dou r by dou y. Now let us see whether these equations are satisfied. Now what will be dou p by dou y? We have to partially differentiate p with respect to y, keeping x and z a constant. So what will the differential be? Differential of y is 1 and of yz is z. So dou p by dou y will be 1 plus z. Now let's see what will be the value of dou q by dou x. So we have to partially differentiate q with respect to x, keeping z and y constant. So this is a constant term, this will become 0. Differential of x is 1 and differential of xz is z. So again it is 1 plus z. So dou p by dou y is same as dou q by dou x. Now what is the value of dou p by dou z? It will be y. Partially differentiate p with respect to z, keeping y and x a constant. So the value of dou p by dou z is y. And what is the value of dou r by dou z, dou x? Again it is y. So again dou p by dou z is same as dou r by dou x. Similarly, we can see that dou q by dou z is equal to dou r by dou y. So all the three conditions are satisfied. So we can conclude that the line integral will be independent of the path because the field given is a conservative vector field. So next what we have to do is we have to find the integral. Now since we know that the given field is conservative, we can find a potential function corresponding to that conservative vector field. Now let us see the steps which we had seen in the previous lecture one by one. So first thing is, we are given p, q and r. Since the field f is conservative, f is equal to grade phi, where phi is a scalar function, right? So we need to find what is phi, then only we can find the integral. So to find phi, first we have dou phi by dou x is p, dou phi by dou y is q, and dou phi by dou z is r, right? So first we will integrate this expression, that is dou phi by dou x equal to p, and when we integrate this with respect to x, what will be the value? What is p? P is y plus z. So when we integrate this, we get dou phi by dou x, integration will be xy plus xyz plus a function of y and z, that is we are naming it as g. So we obtained the expression of phi is equal to xy plus xyz plus g of y comma z. Now what we will do is we need to find the value of g, right? What is the function g? So for that we are going to partially differentiate this given expression with respect to y. So what will be dou phi by dou y? Dou phi by dou y will be x plus xz plus dou g by dou y. right? G is a function of y and z, so partial differentiation, z will be a constant, so we need not consider about the term of z, so it will be dou g by dou y. Now from the beginning, in the beginning we had seen that dou phi by dou y is q, and what is q? It is x plus 3z cube plus xz. So let us compare this value with the value which we have obtained right now. So comparing, we get x and xz, both the terms are there. So we get dou g by dou y is nothing but 3z cube. So once we know what is dou g by dou y, we can obtain the value of g. How? We just have to integrate this expression. So integrating with respect to y, we get 3yz cube plus hz, where h is a function of z only. So we'll substitute this value in the phi which we had obtained. So the phi will be equal to xy plus xyz plus 3yz cube plus hz. Now we need to find the value of h of z. We need to find what is the function h of z. For that, what we'll do is we will partially differentiate the given expression of phi with respect to z. So what will we get? We'll get dou phi by dou z. Dou phi by dou z is xy is a constant, so this is 0, and here it will be xy plus 3 into 3 9yz square plus h dash of z. Now we know dou phi by dou z is r, and what was r? R was supposed it was given 9yz square plus xy minus 1. So comparing these two expressions, we get h dash of z is equal to minus 1. So from this we can find what is the value of h of z. What will be h of z? H of z we can obtain it by just integrating it. What will it be? It will be minus z plus k, where k is the integrating constant. Now if we leave behind the integrating constant concept, we will get the value of phi to be phi is equal to xy plus xyz plus 3yz cube minus z. Okay, so this is our potential function corresponding to the conservative vector field which was given to us. Now we are asked to find the integral from 1, 1, 1, 2, 1, 4 f dot dr. So that is nothing but phi of 2, 1, 4 minus phi of 1, 1, 1. So once we know phi, we can apply this concept to find the value of the line integral. So the value will be, you can just evaluate it. We just have to substitute the value of xy plus xyz plus 3yz cube minus z. We'll substitute 2, 1, 4 and 1, 1, 1, and we'll obtain it as now 198 minus 4, and which is 194. So this is how we do the problem to find the conservative, to find the potential function of a conservative vector field. So this is an example. We shall do more problems as assignment to make the concept thorough. So next is just a brief topic. It is called the conservation of energy. It is just relating the concept of the conservative vector field to the potential and kinetic energy and all. So let's just see. If the field is conservative, it states that the law of conservation of mechanical energy holds. And what is that law? That law is that for a moving particle with a conservative vector field or a conservative field, the kinetic energy plus the potential energy is a constant. Okay. Now there is an example of a non-conservative vector field, that is a frictional force such as air resistance and all. Okay, we are moving against the air. So a frictional force such as air resistance is non-conservative, and non-conservative forces are dissipative in their action, and their action reduces the kinetic energy without a corresponding increase in potential energy. Or in another way, we can say that the work done depends on the path, and hence the field F is non-conservative. Okay, so non-conservative forces are dissipative. The non-conservative forces are dissipative, and that is the work done, that is integral over C F dot dr, depends on the path, and hence the field will be non-conservative. So this is how we relate the concept of the conservative vector field to various terminologies in physics and all. So there are applications all throughout. There are of the things that we are learning. We are not just doing some theorems and some problems. There are applications to each and everything that we are doing. So in that we shall do more problems related to the same as assignment and all, and just keep the points and the concepts in your mind clear. So with this we shall wind up today's session. Thank you. Stay home and stay safe.